Hello and welcome to this first video on getting started with the Hansadrone SaaS solution. Hansadrone solves the final 50 feet problem of drone delivery. How to navigate and guide a drone to the customer even if his position is not exactly known and if there is no landing location. Hansadrone allows to define a safe approach corridor and to guide the drone through that corridor during the approach flight. The service can be used with any drone and can be integrated to any drone flight management system through an open API. The service consists of the following elements: a mobile app running on the smartphone of the customer and a cloud-based backend with an API to connect to the drone flight management system. We also have a dashboard that we call Cockpit to visualize the data stored in the backend. This is what we want to set up today in this video. No drones needed for this part. So let's get started. To use the service, simply register at hansadrone.com/development and you will get your API key by email. As we are in MVP mode right now, one API key is good for a single combination of smartphone and drone at a time. If you need more keys, just drop us a mail. First, we need to install the mobile app. You can download it from our website. The app is currently available for Android only. This is a standalone app for the MVP. Later, there will be an SDK for Android and iOS that you can include into your apps. Enter the API key. The app should start with a camera preview image, some debug infos and a disabled button. Turn your phone around 360 degrees to see if the compass values in the debug screen behave correctly. If not, move your smartphone in the form of an 8 a couple of times to calibrate the compass. When done, let's put the phone aside for a minute and set up the backend as well. Open hansadrone.com/cockpit and enter your API key here as well. Check the box to save the key in a local cookie so you don't have to enter it every time. No worries, we don't use this cookie for tracking. The cockpit uses the same API as the drone would use to get and set data from the backend. We see the mobile status has already changed to connected as the app is still running. We can use the drop-down to set the drone status to connected as well. To start the delivery, set the drone status to available. This will trigger the UI flow in the app. On the phone, a notification pops up to inform the customer that a package is available for delivery. He can now initiate the delivery at a time of his convenience. We start right away. The delivery just needs 3 simple steps. Step number 1, proceed to a location where you have a clear view to the sky. This can be someplace outside, a balcony, or just an open window. I'm sitting on my balcony, so all good. Step number 2, with the camera, define the direction from where the drone could best approach. This direction should in particular be free of obstacles like buildings or trees. So let's select a suitable direction. We have trained an artificial intelligence model to identify clear sky. A red frame means there are obstacles, and if the frame turns green, the button gets enabled and we can define this direction. In step 3, we confirm the selected corridor is okay and legal to use. In the cockpit, we see the mobile status has changed to defined and the data of the selected corridor is loading. We have latitude, longitude, inclination angle and compass angle. We also get the image of the corridor. From this data, a fixed point is calculated as the intersection between the corridor and the cruising altitude of the drone as a start point for the approach. The cruising altitude of the drone can be set here. All the data is shown on a map as well. The corridor data is a 3D object that can be used for further validation to match against no-flight zones, 3D building data and other third-party data to ensure this corridor is really free and legal to use. When all is validated, the drone is ready to take off and fly towards the fixed point. We can simulate this arrival by setting the drone status to at fixed point. In the app, a pop-up notifies the customer that the drone is arriving and to please point his smartphone towards the previously defined corridor. The drone starts sending out light signals for recognition. I use a little red LED to simulate this. We use red light for now, but it can be any color later. The light will also have coded signal to uniquely identify the drone. The small rectangle on the screen follows the recognized light. Deviations are calculated from the recognized drone position relative to the center of the corridor to allow the drone to correct its position. If I move the phone away, the corridor turns red automatically and the drone will stop. The deviations are sent to the cloud and can be seen in the cockpit as well. The drone will now use this assistance to approach the customer. It will step by step approach through the corridor and correct its position based on the recognized deviations. So we have a closed control loop during the approach flight. So that's it for now. You're all set to make your first delivery. As a next step, please also watch our videos on how to use Hansadrone to fly a drone in a simulator and how to fly a real drone. We have an example MAV SDK Python script available to connect to any Mavling-enabled drone like a PX4 or Ardu Pilot, but the API is generic and can be used with any drone. As mentioned, we are in MVP mode, so any feedback and comments are welcome. Just send us a mail to contact@hansadrone.com. Thanks for watching, fly safe!